Hello, hello. Wanted to put this announcement at the front in case somebody's watching this later, but mock tests are on my calendar now. This Saturday from 1 to 2 p.m. and Wednesday from 2 to 3 p.m. And those are the times where I am going to be administering those. They're just going to be 3 free response questions. They're going to be 45 minutes long. And you do get a 5 out of 5 in the quiz category for doing them. So that's pretty cool. Uh-oh. Left my sound on my computer wrong. Sorry for the echo. Hello, hello, and welcome to Michael, Caitlin, Maddie, Aspen, and Natalie. And here is the opening question. Wow. And Sam. Wow. Sorry I haven't gotten around to grading more of the homework submissions, but I will be doing that after the stream today. Hopefully get through like an hour or more of grading those. Hello, Rose. Welcome. Those of you who did the homework, who maybe had already looked at the 2019 released free response questions, may have realized that the homework was the first 3 questions off of there. So it is, if you had not seen those questions before and you did pretty well on the homework, that's a really good sign, because that's the most like the actual AP test that you can possibly get. So that's pretty cool. So yeah, I would like you working on this question here. It's a table question. It might be one we've looked at before, at least one very similar to this. But it requires you to know your value theorems. Also, upon reviewing the questions for the homework, I realized I graded a couple of them wrong. So some of you maybe should have received more credit. If I graded yours already, you maybe should have received more credit, because they accepted a few different answers for a few of them. And I'll go over that shortly. Hello, Chelsea. Hello, Keith. Welcome. Welcome, Kelly. We have an attendance document again, so I'm not doing another online graded homework because the mock tests will all be graded, and between the mock tests and this homework, that's like 10 to 15 hours of grading probably, so I'll be plenty busy for the next few weeks grading. Joyous times. My favorite part of the job. Mock tests are Saturday at 1 p.m. and Wednesday at 2 p.m. So during the normal stream time on Wednesday, we are going to instead have a mock test administered on AP Classroom. Do we have to sign up for a day or just show up? Just show up. I'm going to be enrolling everyone, but only the people who show up on AP Classroom are going to be in the test. And I'm just going to have it open during that hour. And it's going to be 3 free response questions from the unreleased secure document AP tests thingies that they have on AP Classroom, AP Online, whatever you call it. So they will be specific mock test questions. And that's kind of the best we can do for mock tests, because this year's test is weird. I'll be putting more directions on my homework calendar. So the homework calendar link is the place to look for any updates. I'll also be sending out an email, maybe today, maybe tomorrow, explaining the mock tests and what the protocol is and how things are working and all that. The mock test is designed to only take 45 minutes. I'm making an hour window just in case like people are late or whatever. But I'm gonna be like monitoring the stream during the test status during the window to like make sure kids aren't showing up for just like 15 minutes of it. You know, saying I don't know for half of them. Kozar. And then trying to get credit for it. So it's that kind of thing. People who grind and try and stuff are gonna have no problem getting all their credit. YouTube is broke? Okay. Why did it take 5 minutes for the live stream? I don't know, man. I found it first time this time. But my new tool that seems to be working well is to type in LibertyMathandStuff all one word and then space live. And I've been finding it. I don't know, man. Yeah, YouTube live has a little bit of lag time for giving updates on whether or not it's live, and I have a hard time finding myself sometimes. So I apologize and realize that no worries, Liam. I just want people to try instead of write. I don't know. That's kind of the big idea on those. So to get credit, I want you to actually have grinded on math for 45 minutes. That's what I'm looking for. And just an FYI to people doing those online submission homeworks, the easiest for me to grade or whatever have been the people who like do it on a notebook piece of paper, take a picture of the whole problem and put that in. There is a sign-in sheet today. It's linked on my homework calendar. I'll put a link in chat later, probably. Right, I'm logged in into the right account, right? Yeah, cool. Oh, and yeah, to Liam clarify that a little more. I'd rather you just get it wrong than right. I don't know. That's kind of what I'm looking for on the mock tests to receive credit. Because if you try, you might get it right. So I'd rather people just give it their best. Because you absolutely don't want to write like I don't know on the AP test because there's just no point in doing that. Also, Liam, you're one of the people that should have gotten a couple more points because I graded you wrong on one of them, at least one of them. So I was gonna go back and grade a bunch after this and maybe fix a couple people's. Let me know when you're done with these. And hello to the people who said hello. Good morning. It's afternoon. Hello, Victor. Welcome. Hello, Elizabeth. Welcome. Feels like morning to me, though, because, yeah. Read the news for an hour and a half before getting out of bed today. It was one of those days. I don't usually have that big of a problem with bad handwriting, to be honest. I have bad handwriting. So, I had it for a lot of my life at least. I've gotten a little better lately, but when I write words, I'm way worse than when I write math. Wake up at 10:40 p.m. Huh, all right. Or 10:40 a.m. Whoops, p.m. would be flip schedule. Even my brother doesn't wake up that late. He's been waking up at like 3 usually. Done, but you don't know your theorems. Yeah, theorems are helpful on this, for sure. For sure. Another good morning from Carly, so there's agreement there. And Elise is here. Hello, Elise. Done. I don't know my theorems either. Yeah, 1, 2, and 3 are all theorems, and 4 could be 1, maybe. But I know 1, 2, and 3 all have theorems in their name, or A, B, and C, whatever, in this case. Uh, so... So this is one of those questions where it talks about f and g, but it gives h and then asks about h a ton. So it's one of those evil kinds of questions. So you should have found h prime of x early on. You know, just for giggles. I'm not sure it's even necessary for A, but like it will be necessary for later parts of this potentially. So explain why there must be a value where the actual graph of h goes through -5. So I don't need the derivative for this. All I'm gonna do is, wait, did you already talk about the mock test? Yeah, I'll go back and talk about it again after this question, since getting a lot of questions about that. Don't worry about it. Since h is f of g of x minus 6, then I'm going to do f of g of 3 minus 6 and f of g of 1 minus 6 and get these two values. And g of 3 is 4, and f of 4 is -1. So -1 minus 6 is f of g of or h of 3? Yeah, that one. G of 1 is 2, and f of 2 is 9. So this is 9 minus 6. So we know it goes from -7 to 3, and it's differentiable, and g is strictly increasing, so we know actually quite a bit about it. Because it's differentiable and going from -7 to 3, then it has to go through -5 because of the intermediate value theorem, or as the AP test seems to call it, they call it something else. I don't remember. No, they call it the intermediate value theorem. Never mind. They call the other one the extreme value theorem, but that's not in this case. All right, so intermediate value theorem. So that's our theorem for this one. Says that if continuous, so it actually doesn't even need differentiable for this one. Then goes through all values between -7 and 3, including -5. And it's continuous because f and g are continuous. Oh yeah, no worries. Okay, so part 2 says explain why there must be a value, again, between 1 and 3, where the derivative equals -5. And actually, I didn't even need this derivative for this, because all I do for this is use these two values, -7 and 3. And I do y2 minus y1 over x2 minus x1, and I get -10 over 2, which is -5, which means because of the mean value theorem, it has to go through -5. The slope has to go through -5. To go through -5. Wow, why did I put an E at the end of through? Yikers. This is the writing English. My handwriting is horrible. And this requires differentiability. So I do have to mention that both F and G are differentiable. So H is differentiable. So A was intermediate value theorem, B was mean value theorem. Could you also go over to how to apply the squeeze theorem? Yeah, the squeeze theorem's super ultra omega lame. Omega. I'll talk about it after this, because it's not in this question specifically. All right, so that was the first and second. I didn't actually need this derivative for either of those, A or B, because all I needed to do was plug 3 and 1 into this function and use those two values to prove that it has to go through those points and it has to have that slope somewhere. So really no calculus in those first two questions, just calculus ideas. The third part says let W be this different thing, the integral from 1 to g of x of f of t dt. Find the value of W prime. Well, this is the second fundamental theorem, so another theorem that says if you take the derivative of an integral, all you do is plug in, whoops, I goofed. You plug in the bound, g of x, and you multiply by the derivative of that bound, g prime of x. Like so. And then you just plug in 3. So all we needed to do is figure out f of g of 3 times g prime of 3. And so this is that second fundamental theorem. It really is just that. We don't need to get f prime because the derivative of w just gets rid of the integral, so we're left with just normal f instead of the integral of f. So there's no extra stuff we need to do. All we need to do is plug in g and multiply by the chain rule part, the derivative of g. G prime of 3 is 2. G of 3 is 4. So f of 4 is -1. And so that was pretty easy. Worked out pretty nicely. Plugging stuff in after we got the right equation. And the last part is easiest or hardest. I mean, kind of just depending on your comfort level with inverse functions. So, for this, we have this inverse function of g. Note it here, and this confused me when I first looked at it, that f is not the inverse of g. G, -1, is the inverse of g. So normally we say the inverse function equals 1 over f prime of, the x value, like the actual original x value. And we can use that same logic here. The derivative of the inverse equals 1 over. So we're trying to find the derivative of the inverse of x, and so we're going to do 1 over g prime of the actual x value. So we need to find the actual x value. This is the input to the inverse, so I need to look at where this is an output of g, because this is an input to the inverse. And 2 is an output of g at x equals 1. So this is 1. And then I just do 1 over g prime of 1. G prime of 1 is 5. And so my slope of my inverse is 1 over 5. And now I just use the fact that I know the x value is 2 and the y value is 1 that give me this point in the inverse. So I'm back to inverse land. I switch back to normal G land to find the slope. But in inverse land, x is 2 and y is 1 because x and y are flipped. And so my slope is 1/5 and my point is 2, -1. And all I do with this is I do y minus y1 equals slope times x minus x1, and I'm done. Sweet. So, to review what happened there, I had... So, they tell us even in the question that in my inverse function, my x is 2. But in my inverse function, x and y are flipped. So I want where in g, the y value is 2. And that's when x equals 1. So I know from this that in g, 1, 2 is a point on the graph. And in g inverse, 2, 1 is 1 is a point on the graph. Did I goof with this -1 garbage? Oh, so much. Feels bad. Why did I put a -1? That was goofy. All right. So yeah, the point is 2, 1 is a point on the graph in the inverse because x and y are flipped. But then to find the derivative of the inverse, all I do is g -1 prime. Writing that is so horrible every single time. I am never happy with how 1. So I just look at g prime of 1, which is 5, and I get 1/5 as my slope. And now I go back to inverse land, where 2, 1 is my point, and I just do y minus y1 equals slope times x minus x1. And that's how I got y minus 1 equals 1/5, parentheses, x minus 2. And it should have been +1, so sorry, Drew. I messed that up. I don't know why I wrote that. There was no -1 anywhere in the question. Except in the, I guess, inverse writing. And so that's that inverse process. It's a little convoluted. It's a little confusing for sure, because input and output are swapped. But really, you remember in inverse, x and y are swapped. And that's the key piece there. And so when you go to normal land, which you go to figure out the slope, because the slope of the inverse is 1/g prime of the x value of the original function, then you have to swap the x and y. And so your y is 2, and you look for where y equals 2 and say x equals 1 there. So hopefully that makes a little more sense, but inverse problems are tricky because of that swapperoonie. Okay. Okay, to talk about the squeeze theorem real quick, I'm going to go to, whoops, not to that. Boom, 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 boom. Here. Squeeze theorem's super, super lame. I hate it. It's such a stupid theorem. Anyways, it says if you have two functions and one's always bigger than the other one, and if they meet at a point, it means that a function that's always in between the two functions must also be equal at that point. That's it. So what they say is they call this like f of x, and they call this g of x, and maybe they call this h of x, the guy that's always in between. And they say for every value, f of x is greater than or equal to h of x, which is greater than or equal to g of x. Basically saying h is always in between f and g. And then they say, you know, if f of x equals g of x, then h of x also equals, you know, f of x and g of x, because it's in between them. That's the squeeze theorem. And did I go off the... No, we're chilling. So this is really, really unspecial. I'm sure it helps you in some really abstract case to have such a simple theorem, free up some bandwidth, but it's like so lame of an idea. It's so simple. And I don't mean that in like the demeaning way. It's like actually just like if you go between two functions and they never touch, the squeeze theorem doesn't apply. But if two functions, if one's always on top and they do touch at a point, then the squeeze theorem applies, and anything that's in between them will also go through that point. Wow. Yeah. Squeeze theorem. All right. Moving forward. Oh, yeah. Moving backwards, actually. Mock tests. It's a 5 out of 5 in the quiz category. It's the two opportunities are this Saturday, so May 2nd at 1 p.m. and next Wednesday, May 6th at 2 p.m. And they're an hour long. You're actually getting a great deal because mock tests are usually like 3.5 hours long. And this year, they're 45 minutes. Expect to have it take an hour, maybe some extra time to log in or because you show up late or anything like that. But that's what mock tests is like. I'm going to be sending out an email with more directions either today or tomorrow. You don't need to show up to a stream or anything. You're actually just going to show up in AP Classroom. I'm going to have a mock test event created. Could we have more than one mock test? Yeah. The Saturday and Wednesday mock tests are different mock tests, so they're independent events. Is it graded? Yes, but if you try and give good submissions for them, so Liam, no Word documents. Good submissions are like pictures of your work, that sort of thing. Which is what most people are submitting, then you get credit. I'll be grading you to give you feedback, but you'll get a 5 out of 5 quiz if you do it. We'll have an actual mock test demo released by AP2, right? I sure hope so. I mean, these are actual AP mock tests released by AP here, but it's not like a actual program they have. It's just the same as the homework, but I can run a session, and so it's a live session, and so I end it at 2 hours, and they're unreleased questions. So that's the mock test thing. All right, I wanted to talk about the homework. Which many of you have done, and I have not graded all of you, so don't worry, I will grade you at some point. Hopefully today for many of you. And I wanted to kind of talk through these questions. And kind of talk through when I graded them what a lot of people were doing incorrectly. So first of all, a lot of people got one right because you just had to integrate from 0 to 5 of the number of fish entering, which is conveniently called E of t. But if you just integrate from 0 to 5 of E of t, since it just wants how many enter the lake, then you should get the answer. And I mean, it's just on a calculator, so it's 153.458. And it says round it to the nearest whole number, so you say 153 fish enter the lake. What is the average number of fish that leave the lake? This is almost exactly the same, except with the leave equation, except it asks for the average. So what we're going to do is integrate the leave equation from 0 to 5 and divide by 5, and that will give the average number of fish that leave the lake per hour. So the average rate that fish leave the lake. Is the interface going to be similar to the online classroom? Yeah. No, we don't know about that, at least as far as I know. I have not been told. Her Grammarly messes with the AP software. Really? I don't know those answers. They said May 3rd they were going to talk about that, I think. So that's Monday, if I remember right. Or May 4th. I don't know. They mentioned something about that being released sooner, and they said it wasn't going to be the same as AP Classroom. So I don't know for sure for the AP tests. I'll be trying to give you that soon. All right. Anyways, moving forward. This answer, by the way, if you do this on your calculator, is 6.059. Now, something a lot of people did, and just a big PSA, based on the ones I've graded, is a lot of people rounded this to the nearest whole number. It did not ask you to do it on this question. So just because it asks you in A doesn't mean to do it in B. So it actually wanted 6.059 fish leave per hour from 0 to 5, t equals 0 to t equals 5. And it wanted something like that. Can you grade the optional practice FRQs? You can by Googling the questions. That's more of an essay with. Okay, I'm not going to answer distraction questions because I want to keep moving. All right. When is there the greatest number of fish in the lake? For this one, it really helped to graph E of t minus L of t. Because E of t is the rate of fish going in and L of t is the rate of fish coming out. So if you graph this, you figure out when the number of fish leaving passes the number of fish entering, and that is the maximum point. So if you look at the graph, it looks something like this, roughly. And at some point, the fish leaving, it hits this point, and it does stuff after this. But the point is it hits a point where the amount of fish entering is no longer bigger than the amount of fish leaving. And that point is what you're looking for the maximum. Now, there's two different ways to do this, and you need to have these to provide justification. So first of all, that point where I'm talking about, where it switches from increasing the number of fish in the lake to decreasing, is at 6.204 roughly, or 6.20. I should use more decimals for intermediate stuff like this. 2.0356 here. And one way to test to see if this is a maximum is to test these three values. The beginning, the end, 0 and 8 are beginning and end. And this value, our only critical point, and see which one's a maximum or a minimum. And it turns out 6.20356 is the biggest. It's 135 fish, roughly. The other way to do it is to say I'm increasing before, I'm decreasing after, so it has to be a maximum at 6.20356, because the number of fish is less on either side. That's the high point. And so either way, that's a good justification. And so that point, t equals 6.204, was the right answer for the time that it's at a maximum. And the last part says, is the rate of change of the number of fish increasing or decreasing at 5 a.m.? And so all you have to do for this one is, well, this one's a little more complicated because it says, where is the rate increasing? This is the second derivative because increasing or decreasing is a rate, and so we're taking a rate of a rate, so a derivative of a derivative. And so we actually need to take the derivative of E and L. And a lot of people didn't do this on the homework. So you want to do like E prime of t minus L prime of t to figure out if the rate of change is increasing or decreasing at 5. And if you figure these values out, which you can do just by doing if you have a calculator, you can do numerical derivative at a point. Or you can graph the calculator and do a graph trace at 5, or, I mean, there's just a bunch of different ways to do this without actually having to do any of the math, which is nice. But yeah, if you do any of those, you get that the net between these, so E prime of 5 minus L prime of 5, is negative 10.723 or so, and that's negative, so it's decreasing. So a lot of people just did E of 5 minus L of 5, and that's positive and said increasing, so if you got that wrong, that's probably why. So, on to the second question, which was about a particle moving left to right. So this is another type of question we had done this year. So we're given a velocity. That's the left to right. It's like positive to the right, negative to the left, so on and so forth. So the first part says, explain why there must be one time between these values where the acceleration equals 0 meters per hour squared. And the big idea is to look at 0.3 and 2.8, realize they have exactly the same velocity, do the mean value theorem, get 0, and so say v prime, or a, needs to be equal to 0 at one point on 0.3 to 2.8. And you need to mention it's differentiable because v of p is differentiable. So that's the whole mean value theorem brought back. Mean value theorem. All right. A down. B was just a trap sum. So first interval was 0.3 wide. For traps, you just let me clear everything. For traps, all you do is go halfway in between the two y values, so 27.5. Next interval is 1.4 wide. And halfway in between negative 29 and 55 is 26 divided by 2, 13. And next interval is 1.1 wide, and halfway in between, oh, those are the exact same, so 13 is halfway in between. And you just add all these together, and I'm cheating and looking at the answer. Ha ha ha. 40.75 is the answer. This is a calculator question, so this is that calculator step. Okay, so then C says a second particle, so unrelated to this table, moves along with this janky equation here that, thank goodness, this is a calculator question for. Find the time interval during which the velocity of particle Q is at least 60 meters per hour. Find the distance traveled during this period. So for this one, you graph this on your calculator, and this thing goes above 60 at some points. And you find those 2 points. Those 2 points where it is above 60. Sorry, the 2 points where it goes through 60, where in between it's above 60. And so you graph this. Daikun, no, because it's asking about a rate. So no. Anyways, what was I doing? Oh, right. Okay, so those 2 points, I was going back to my work to look at the points, are at 1.866181 and 3.5197 or 19174. Yeah, cool. So the big idea here is that you need to include this many decimals, where a ton of people got this wrong, where they only said 1.86 and 3.52. Don't do this. You need many more decimals than this for intermediate answers, because these are the bounds that go on your integral that helps you solve this question. So this is where a lot of people lost credit, because they got an answer that was like within one of the right answer, but was not accurate to 3 decimal places. So just big warning on this. Make sure you use lots of decimals for intermediate answers. Then you just plug in, VQ of t, VQ of t, this nonsense here, and integrate between those bounds, and you get the distance. Oh, sorry, you have to absolute value this, but it doesn't matter because it's above 60. And you find the distance traveled when the velocity is at least 60 meters per hour. There. How do I make my TI Inspire 4? Yeah, you go into settings on your graph. You go into menu settings, and you change the float to like 8 or 9 or something. You're probably on float 4. So yeah, you on graph, you go to menu settings, and then change the float to be more than, you're probably on 4 or something like that, and you want that to be like 8. That just shows you a lot more decimals. Do you do that even if it doesn't say it around? I'm confused. For intermediate answers, always do a ton of decimals. Like, do way more than required, because your answer needs to be accurate to 3 decimals. So for this one, you had to have the answer. A lot of people got like 105.8, and you had to have 106.109 as your answer. So you needed to be accurate to this much, and you weren't if you rounded this early on. So that was a big warning for a lot of folks who should have gotten that right based on their work. All right. Then we're staying in Q land. So at time t equals 0, particle Q has a position of negative 90. We're using the results from part B and the function from part C, so this V of Q thing, to approximate the distance between the particles of P and Q at t equals 2.8. So all we do for this is negative 90 is the start position, and we integrate from 0 to 2.8 of our V of Q. That gives us the position of Q. VQ of t. I totally wrote that wrong. So that's position of Q. And the position of Q is 45.938. Okay, and then for position P, or for the position of P, we take this 40.75. Which is the integral from 0 to 2.8 based on our approximation. And if it starts at the origin at time equals 0, well, then it's just at 40.75. So we just subtract 40.75 from 45.938, and we get that they're 5.188 roughly meters apart, because remember, our trapezoidal sum is an approximation. So it's 5.188 meters apart. And so I'm not sure how liberal. Oh, Liam, every calculator question, and your entire test is calculator for the record, needs to be accurate to 3 decimal places. 3 decimal places is the AP calculus rule. You just do 3. Oh gosh, I'm getting a phone call. Ignore it. Okay, so that is that question. So big ideas in there. Intermediate answers, which these are, use lots of decimals. Otherwise, I think things were okay. Okay, this question now. Probably the easiest of the bunch, in my opinion, because I like no calculator questions. But actually, one I think people did the worst on this one. So maybe not the easiest, maybe the hardest. Anyways, it tells us the integral from -6 to 5. That's from here to here. That's more than the interval. Okay, so we want to find the integral from -6 to -2. I know nothing about this, but what I do know is how to find the integral of f of x. I find the area of all these parts. So I'm going to find the area of all these parts. This is 1/2 1 times 1, so that's a half. This is 1/2 1.5, which is how long the interval is, times 1. So it's 0.75, but like negative 0.75 because it's below the axis. This is 1.5 by 3, so I do 1/2 1.5 times 3, that's 2.25. And this last area here is the whole square here, 9, minus the semicircle, which is, or the quarter circle, I guess, which is 1/4 pi 3 squared. So 9 minus 9 pi over 4 is this remaining piece. Okay, so now all of my stuff that I know in the picture is 1/2 minus 0.75 plus 2.25 plus 9 minus 9 pi over 4. I can combine all the like terms. So 2.25 minus 0.75 is 1.5 plus a half is 2 plus 9 is 11. So 11 minus 9 pi over 4 is the area under the curve, the accumulation under the curve, the integral from -2 to +5. All right, now that I have this, I can just do 7, which is the whole integral, minus this crap, and that will give me the remaining piece. So I did 7, the whole integral from here to here is 7, and I subtracted the part in the picture. And if you do this, you get -4 for 7 minus 11 plus 9 pi over 4. And that's the answer for A. B was actually like our properties of integrals section. You just integrate. 2f prime of x integrates to 2f of x. So we just lose the prime. And 4 integrates to 4x. Then you just plug in 5. So you get 2 times f of 5 plus 20 minus 2 times f of 3 plus 12. Did I close too many parentheses? No. Chilling. And then you just plug in f of 5, which is 0, and f of 3. I need to erase some of my graphs so I can actually see what's going on here. Okay, so f of 3 is harder to find. I'm actually going to have to find this value, which is a little bit of a pain in the bottom. Should we put unit squared? No, you don't need to. You don't need to put units if it doesn't ask for them. So let's plug in what we know. 2 times 0 plus 20. Easy. That's 20. F of 3, crud. I'm going to have to figure this out. So I need to find this value, and this value isn't like a whole number piece or whatever. So I'm going to have to figure it out by figuring out like the equation of the circle. And the circle, has like a center up here. So I what's the right way to go about explaining how to find that value? It's good your AP test is so short this year because you could totally x minus 5 squared plus y minus 3 squared equals r squared. You could just do that. Oh, it's in the problem? Oh, wow. Thanks, guys. See, this is why you read. Oh, good. Okay, so anyways, f of 3 is totally 3 minus root 5. Thank goodness they told us that. Otherwise, that's way harder. I've totally done this question before, which may surprise you because that's pretty blonde of me. Feels bad. I can't live down my hair color as a child. Anyways, 20 minus 6 plus 2 root 5 minus 12 if I distribute that negative sign to everything. And I kind of did 2 distributions in one. And a lot of people goofed up that distribution there, but whatever. And 20 minus 6 minus 12 is 2 plus 2 root 5, which is the final answer. This is honestly hilarious. Yeah, totally. And the worst part is I've done this question multiple times, and I still got that wrong. I would have actually found it on the AP test. Feels bad. All right, last part. A lot of people got this dude wrong, but for this dude, the big idea was to realize that at 1, f prime is 2. 10 to the 1 is 10. So you get 4 on top. On the bottom, f of 1 is 1. And the arctan of 1, you didn't even need to find it. They honestly accepted this answer. But the arctan of 1 is pi over 4. That's where sine and cosine are the same. And that's 4 over 1 minus pi over 2. And that's all you needed to do for that. But they accepted 4 over 1 minus arctan of 1. Alright, apologize for being derpy, folks. We only have one question. Oh no, we're done with looking at the homework questions. Thank goodness. So again, these were all off of last year's AP test. So these are really good questions for proxies for where you're at. So this was a really, really, really good piece of homework as far as accuracy with the actual AP tests. Some notes, I talked about these yesterday, but these were actually all off the 2019 AP tests. It takes me about 5 minutes to grade each of these, roughly. A little lower for the people who do really well, and a little longer for the people who maybe do things a little unorthodoxly, or who upload individual documents for A, B, C, and D. Those take me a little longer because it just takes time to open all this. So yeah, the grading, I'm gonna have a ton to grade over the next few weeks, actually like 10 hours between the mock tests and this assignment. So if you're wondering why I don't grade these more often, that's why. Use intermediate value or intermediate values. Use a lot of decimal places for them. Change the float on your calculator to be greater than like 3 or 4. Make it like 9 or 8 or 7 or something, some bigger number. And being accurate to 3 decimal places is really important for online pieces. I barely managed a 5 on this homework. Oh, okay. It gives you the point. Yes, you can honestly look this up and it will give you the points. If you look up 2019 AP Calculus free response, the first link is scoring guidelines and you can grade it yourself if you would like. But I will be grading them for you so I can like put it in the gradebook and stuff. Okay, I was going to do another question, but we out of time. And I have other things. So I want people to get to where they're going to get. Homework is back offline. I linked a bunch of questions. You can Google these questions again and grade them yourself. But these are back offline. There's a document for today. I understand if you have to get off somewhere, or if you watch this late, no problem there. I can link the live stream piece here. This is the document where you can get attendance. I am grading this today, not the assignment for today. The homework link doesn't work. I didn't have access. Oops, did I mess that up? Sorry, folks, I derped today. I'm showing signs of weakness. The link worked for me, and I linked it differently, or to a different account. Aspen is correct. Okay, crap. Yep. Copy link. Copy link. I'll try to fix it now. Let me know if it works. Best way is to do it in incognito mode for I re-uploaded it. We're good now? Okay, cool. Groove is good now, so sweet. All right, cool. I just switched it to public, so maybe that was the problem. All right, awesome. Well, hey, thanks for showing up. Thanks for putting up with me derping. Dude, seriously, going over like 4 free responses in a row is heavy. Your brain turns to mush at a certain point. So, yeah. I apologize for my derpiness. Bye-bye.